All right, what questions do you all have for me today? Your email has just now shown up. So the first question, should equilibrium constants have units, and if so, what are they? So equilibrium constants are actually unitless, and they go back to the big definition for Q. So if you look at what Q is defined as, it's the concentrations divided by the activities raised to the reaction coefficients. And our activities here have units of molarity, as do our concentrations. And so what ends up happening is in our expressions, we end up canceling out all the units of molarity. Now, because of how we define the activities, we rarely if ever see the activities in the expressions for Q. But this is basically why they end up having no units, is that the molarities are actually canceled out by the activities which are found in the expressions for K, Q, and Q. Will be asked you thermodynamic problems with tables and the tests? Yes, you will. So to give you an example of how to do one of those, just let me bring up the packets. So in the packets, come on, there you go. Stop. Thermodynamic problems with tables. Let's say we work this top one, CH4Cl2. So I'm just going to write it on the board. These are actually pretty trivial problems to do compared to the ones that you had to do before with the without tables. So to solve these types of problems, what you do is just write out the Hess's law expression for the reaction for both the delta H and the delta G. So this is the H of CH3Cl plus the H of HCl minus the H of CH4 plus the H of Cl2. Gibbs of CH3Cl plus the Gibbs of HCl minus the Gibbs of CH4 plus the Gibbs of Cl2. The expectation is that if you're at this point, you actually know what should be canceling out, so diatomic gases disappear. And to find these values, if you go to the packet itself, you're going to find these values in this table. So for CHCl3, we'll just do the enthalpy. This is minus 101.25. HCl, minus 92.312. And for CH4, minus 74.873. So to solve this type of problem, you just look up these values inside a table. This is actually how it's done in practice. We have whole tables of this. In fact, what I've got, those tables I'm showing you are only an excerpt of about a 1,000-page book that have all these thermodynamic values in them. But if you can do the big Hess's Law problems, you can definitely solve these. They're set up just like the Hess's Law problems, except instead of having to solve a whole bunch of reactions, you just look them up in a table, and the exam will specify which one you're dealing with. So question 3, for pressure dependence, is Q supposed to include RT in the weird-looking XI variable? The XI variable here is the mole fraction. Generally, we're not going to worry about having the RT in there, just so the big thing here is taking away what the pressure dependence is. So as long as you can say if it's first, second, 0, -1, -2, that's the more important thing. Sign of delta H for endothermic reactions versus exothermic. Let me take a look at that really quick. So I'll wait for that load. Someone's asked, why is yttrium hypochlorite not soluble? Big reason is that if you have a polyatomic ion that's not in the highest oxidation state, so there's hypochlorite, ClO, then there's ClO2, ClO3, and ClO4, which is the perchlorate. If it's not saturated with oxygens, what ends up happening is that that molecule will act more covalent than it will act ionic. So chlorate, ClO4-1, that's a very ionic looking compound. Something like ClO, though, even though we define it as ionic because it has that charge on it, it's really going to look covalent, particularly when it binds to metals. So generally speaking, if you have a polyatomic ion that's not like the most oxygen-rich version of that polyatomic ion, so in this case you got a hypochlorite versus chlorate being the most oxygen-saturated, those are generally going to be much less soluble, if not insoluble, than something like the most oxygen-rich form, something like chlorate, ClO4, or nitrate, NO3, or sulfate, SO4. Those act more ionic, which is why they tend to dissolve in water. Okay. Laptop's having issues today. It's because Word's crashing. So while I wait for Word to crash and reload, another question that's been asked, determine the entropy change for the following reactions at 100 degrees C. How do you solve those types of problems? So what you'll notice in the packets, restarting yet, is that for each of those reactions on the entropy page, that last page, here we go. So you see this 2CH4O2 going to methanol. If you go to the enthalpy, that reaction's also there. And if you go to the Gibbs, that reaction's also there. So each of these reactions you see with entropy have been solved previously for delta H and for delta G. So to figure out the entropy change, what you're going to do is just use the Gibbs relationship. So we've got delta G equals delta H minus T delta S. You've got delta G and delta H from the previous reaction, or from the previous part. So to solve for delta S is just delta H minus delta G over T. And that you would convert, you can keep it as kilojoules per mole Kelvin, that you're not technically wrong for doing that. Ideally, you would switch that to joules per mole Kelvin to be more accurate with what's typically reported. But this is actually what's done, because we could try to do the Hess's law for entropy as well. There are defined zeros for entropy, but honestly, if you've gone through the work to find delta G and delta H, you might as well just go ahead and use this relationship. Now, it does look like one of the signs is flipped for the packet, so I'll solve that. Look at that. So for an exothermic reaction, delta H is less than 0. For an endothermic, delta H is greater than 0. So another request, can you solve concentrations from KSP on the study packet? And this one being for the cobalt. So I'll bring the problem up. The question is, if we have cobalt 2 phosphate, what's the concentration of cobalt 2 and phosphate at equilibrium? So we've got KSP here equal to 2.05 to the negative 35. First thing you're going to need is find the formula of cobalt 2 phosphate. So you're just going to use the crisscross rule. We have cobalt 2 phosphate. Phosphate's in a +3. -3. Phosphate's in a -3. Phosphate's in a -3. Cobalt's in a +2. And the way all KSP expressions are written is that we're going to assume complete dissociation. So we're going to have 3 cobalts and 2 phosphates. Now to solve for the concentration, we need our 3 things. We need our expression for K. We need our expression for Q. We're at equilibrium, so we have to set it equal to the equilibrium constant. So this is cobalt to the 3rd power times phosphate to the 2nd power. We also need our IC table. Now again, we can drop the solids in any liquids because they're not going to show up in our expressions for Q. So there's really no physical meaning behind that column. We got cobalt +2, phosphate, ICEE. We're going to assume, since we're looking for the equilibrium concentration, we're going to treat it as the initial concentrations are 0. The change for cobalt is 3 times the extent of reaction because there's a 3 in front of the cobalt. For phosphate, it's 2 times the extent of reaction. So our in value here is 3x, 2x. And what we're being asked to solve for are these 2 squares. So since we need to solve for it, we're not given this row. Odds are we're going to stick this row into our expression for KSP. So we get 3x to the 3rd power times 2x to the 2nd power. So KSP is going to be 108, x to the 5th. So x in this case, let me work it out really quick. So x is 4.53 times 10 to the negative 8. Now, you're not being asked to solve for x. X is just an extended reaction. It is a means to an end. So to actually find your concentrations, these 2 rows are equal. So 3x equals this number, so 3 times this. Is 1.36 times 10 to the -7. Concentration of phosphate is twice this number, so 9.06 times 10 to the -8. And these would be your equilibrium concentrations. Now you can verify this by just sticking these numbers back into this equation. So if you take 1.36 times 10 to the -7, raise it to the 3rd power, multiply it by 9.06 to the -8 to the 2nd power, you should recover this number if you've done the calculation correctly. So, next question. In entropy and Gibbs problems where you find delta H or delta G given a list of reactions, is it possible to not use one of the reactions listed? Yes. The reason being is that these problems are set up to be able to be done by Hess's law or by adding and subtracting. I have definitely had problems where you can't add and subtract, and I've definitely had problems where you can't use Hess's law. But because they're designed to be flexible, you end up with artifacts that are relevant to trying to solve by Hess's law or trying to add subtract reactions. So it's fine if you don't use a reaction, as long as if you're using the addition subtracting method, you end up with the correct reaction. Generally, that unused reaction for the adding and subtracting is used for the Hess's law problems to find enthalpy of formation or Gibbs of formation. Other questions? All right, the discussion board question. So for the discussion board question, this is moving into test 4 material. Wrong one, test out, there we go. So this is moving into the test 4 material with acids and bases. So I'm going to leave you to look up the definition of what a buffer region, an equivalence point of a titration, and a midpoint of a titration is. This kind of goes back to, this is more of a refresher for chemistry 1 in terms of the, if you were at Wake Tech, you would have done a vinegar titration. The relationship from pKa and pH at the midpoint, I will give you a hint on that for now, and that is look up what's called the Henderson-Hasselbalch equation, and that will give you guidance on what to expect to happen at the midpoint. But this is more meant to kind of get you a refresher to go out there and kind of like look at stuff that you covered. You should have covered at least weak acids and weak bases when you were taking chemistry 1, so this discussion board is more of a refresher, but it's definitely in the notes too. So if you go download the notes, there's a whole discussion about, there's a whole set of slides on how titration curves work, the different shapes in the different regions. So I guess to answer your question, like today I won't tell you what the answers are, but definitely Wednesday after the discussion board is kind of come and gone, we can talk about what those points in the curve are. But yeah, the discussion board today is focusing on acids and bases, which is the test 4 material. You're welcome. Using solubility rules in the packets. So the questions here about solubility, these are much more refreshers back from chemistry 1. So in chemistry 1, you should have learned the net ionic equation and the total ionic equation, and you should have been introduced to solubility rules in terms of how to predict what reaction is going to happen. So this material is not explicitly on the exam. The big reason it's presented here is that when we start talking about KSP reactions and we start talking about common ion effect, things like that, not common ion effect, Le Chatelier's how to drive reactions, the assumption is that you'll understand why if I add a certain cation or a certain anion, why that would remove the compound. So again, this type of material is not going to be explicitly tested on the exam. It's more, this section of the packet is more meant to make sure that you kind of remember the stuff from chemistry 1 and chemistry 2. Now, in terms of how to actually solve these types of problems, the recommendation I give my chemistry 1 students is these are double substitution reactions. So to predict the double substitution reaction, your first step should always be to write out the names of the compounds. So we got lithium nitrite plus calcium chloride. Now, for any double substitution reaction, you can either look at it as the cation switching places or as the anion switching places. I recommend just doing the cations. So we end up with calcium nitrite and lithium chloride. And the reason I emphasize students do this is there is a very nasty habit of students saying, well, I'll do this. I have lithium chloride plus calcium nitrite. And they are literally just swapping the cations and the anions. The problem is that this is not a compound, nor is this a compound. So if you go by the names, you're forced to rederive what the compound is. So calcium is +2. Nitrite is -1. So this would make it calcium with 2 nitrites. Lithium is +1, chloride is -1, so it's just LiCl. Now, in order to predict the phases, you're going to use both the solubility rules and the insolubility rules. I think those are present in the notes, but again, this is kind of more meant to be a Chem 1 refresher. So the rule is, if the relevant rules here, lithium in any column 1 metal, so lithium, sodium, potassium, rubidium, cesium, these are all soluble in water. So you have a solubility rule. So anything containing lithium is going to be soluble in water. In terms of nitrite, we have no solubility rule. In terms of calcium, books claim there is a solubility rule. I stopped teaching it because there are just as many exceptions as there are to rules with solubility. So generally I would say calcium does not have a solubility rule associated with it. Chlorine does, though. So chlorine is soluble for everything except for lead, silver, and gold. So lead, silver, and mercury. So because this contains chlorine, this is also going to be soluble in water. And if we look over here, chlorine's in 1 complex. Calcium doesn't have a solubility rule. Nitrite doesn't have a solubility rule. And so in the absence of other information, we're going to treat this as an insoluble complex. And that's pretty much how most of these are worked out. You've got the starting compound, potassium phosphate and beryllium chloride. Write out the name. Write out the name if you switch out the cations and rederive the formulas. And from there, you can backtrack out what the reaction is. And based on the solubility rules, you can predict the solubility of the different compounds. Now, if we were to balance this, that's what you'd end up with. But again, this is kind of more meant to be Chemistry 1 refresher than anything else. But it's meant to kind of help you with the KSP problems so you know what's considered soluble and what's considered insoluble. And especially with Le Chatelier's principal problems. So you saw this with the Le Chatelier's homework for this exam, where it said strontium is used to remove this cation. Well, strontium carbonate's insoluble in water, so when I say strontium is added and it's removing carbonate, you know it's removing into strontium carbonate as a solid. Yeah, it's not being explicitly tested, so it's not like there's going to be this weird like whole Chemistry 1 set of problems on there. It's mostly to kind of get you back up to speed, so this way you don't struggle with that aspect of the questions. These packets were not put together in chronological order. They were mostly put together to address where things show up in class when this is presented into a classroom. And yeah, you're going to kind of notice the packets just kind of bounce around. They're more meant to, the sections are more meant to be kind of standalone. There's not a flow or order to the material. Yeah, I think those are correct. The 9.92 to the negative 11 and the 1.21 to the negative 8 grams per liter. I typically grade the discussion boards in the mornings when I first get logged in, so I'll take a look at it tomorrow. But at 9.92 and the 1.21, that's correct. You're welcome. Other questions? can always tell we're getting close in the live stream because the laptop is slow on me for this, so it starts crashing about this time. All right, give about 5 more minutes. Just a reminder, the exam closes tomorrow night at midnight, so you got through today and tomorrow to take the exam. Go ahead and knock it out. Don't wait till the last minute just because you don't want to get caught outside the exam window. Goal is to have those graded within 1 business day of them being submitted. As for your oral presentations, they've been submitted. I want the exam to take priority getting those graded, so it may be into this week, maybe next week before I get to the oral presentations, but again, this is because I want to prioritize the exam over prioritizing the oral reports. Your reports are important, but I think you want to know your exam grade a little bit more. I think that's really the only big news. We're past, after this test, the next test is actually pretty easy, relatively speaking, to the other exams. So that's kind of going to give you a grade boost at this point, and then the only other exam you've got left is the final exam. We are getting towards the end here, so hopefully sometime soon, especially with the people who got delayed with the lab kits, I can try to put together kind of a quasi-lab grade for you. Big thing with the lab grade, though, is that really the only things you've done are the web assigns. You haven't done well, you got the oral report now, but you don't have like the lab notebook and you don't have the lab practical. So the plan right now, your final lab grades will be visible the Thursday before or the Friday before your final exam. I can't, by law, I'm not allowed to actually send you any information quantitative about your grades. So if you do want to know what you need on the final exam, I can give you a formula, but that's all I can do. And yes, the oral reports are due by the 25th, this Thursday, by midnight. The only thing I need from your oral for you to submit for your oral presentation is just a link to your presentation. Please don't submit the video. Blackboard probably won't let you do it anyway. But yeah, they're due Thursday night at midnight. Submit a link to wherever you've submitted wherever you posted your video, just so I can take a look at it. The plan is to give you a grade breakdown. So if you look in the writing tutorial, there's a rubric for the oral presentation. I'm going to be going off of that, and I'll try to give you a breakdown for each of the sections. And if you lose any points, I'll definitely just put in there where the points came from. But yeah, I do try to give you like meaningful feedback on these talks. If you're going to try to send me a presentation to look over, probably not going to get to it this week because of the exams, because of the other work I need to do. So it's kind of too late at this point to get your oral presentation looked over. All right, if there are any other questions, we'll go ahead and sign off today. Again, we've got live streams for the next 3 days, so if you got questions, send me an email. Again, remember your test is due tomorrow night, or presentations are due Thursday night, and I will see you all later. Thank you all for coming.